Hey everyone, welcome to the world drowning in information and starving for knowledge. From sequencing thousands of genomes to processing millions of transactions per hour, the need for automated data analysis is more pressing than ever. In this era of big data, where 1 trillion web pages exist and YouTube sees 10 years worth of content every day, the challenge is clear. How do we make sense of this vast sea of information? Deviating to the track of machine learning, a set of methods designed to automatically detect patterns in data, allowing us to predict the future or make decisions under uncertainty. But how do we navigate this landscape? Our approach to solve these data challenges is probability theory. It's a versatile tool that can be applied to any problem involving uncertainty. In the realm of machine learning, uncertainty takes many forms. Whether it's predicting the future, determining the best model, or deciding on the next measurement, probability theory guides us through the maze of uncertainty. In this video series, you will learn a wide array of probabilistic models suitable for diverse data and tasks. It's not about a cookbook or an ad hoc technique, but rather a unified view of the field through the lens of probabilistic modeling and interface. We'll deep dive into various algorithms for learning and utilizing these models, providing you a comprehensive understanding of the landscape. Even in the age of big data, the effective number of data points for a certain case might be small. The long tail phenomena reminds us that while some things are common, most are rare. More than 20% of Google searches every day have never been seen before. Statistical challenges such as generalizing from small sample sizes remain crucial even in this era of big data. Now, let's explore the two main types of machine learning. Predictive or supervised learning focuses on mapping input to output based on labeled data. It's about predicting outcomes given a set of input-output pairs. On the other hand, we have descriptive or unsupervised learning. It is about finding interesting patterns in unlabeled data. It's more open-ended exploration without predefined patterns. And there's reinforcement learning, less commonly used but powerful for learning behaviors with occasional rewards and punishments. Though beyond our scope, it's a fascinating field to explore. Before we move on and study more on types of machine learning, let's just understand some general terms used for datasets. Take a look at these three objects. If I ask you to identify them, you'd probably say it's a circle, ellipse, and a square. But how do you know? It's because of certain features you observe in each object. Now, in machine learning, we also deal with features. Think of this as the characteristics you observe in the objects, such as their shapes being circular, square, or elliptical. Additionally, we consider features like color of the object and size of the object. Here's where it starts come together. We have a vector label, kind of a name or a type, and even a number. This vector label works as a class. Similar to how you classified the objects, the machine learning models learn from the patterns in the input dataset and assigns label based on the observed patterns. Now, this thing is done in unsupervised learning or descriptive learning, because over there we don't have labels initially in our datasets. But in supervised learning, you will be already having the labels in the dataset. On the basis of that particular datasets and label, you have to find out the output for the new test cases that you get. So, just like you recognize the shapes of the object, the machine learning system identifies patterns and labels the output accordingly. It's all about understanding the features and recognizing the relationship between them to accurately predict the outcome. I hope you understand all these concepts. So after this, now let's begin to understand about the first type of machine learning, and deep dive into that type, which is called as predictive learning or supervised learning. In supervised learning, the goal is to learn a mapping from input X to output Y, where Y belongs to a set of classes going from 1 to C. If C is equals to 2, it's a binary classification. If C is greater than 2, it's a multi-class classification. Classes are basically labels. In binary classification, the goal is to categorize items into one of the two classes or categories. The output or the prediction can fall into one of the two possible outcomes. Let's try to understand this thing with an example. Let's take the example of email filtering or maybe is living model. So in is living model or email filtering, we can check whether an email is spam or not. And if the email is spam, if the input email comes, it can be either a spam email or not a spam email. So over here, we only have two possibilities or we only have two labels or classes. In the similar way, if you want to check whether a thing is a living thing or not, over there also you are going to add only two classes. First one is living, is a living thing. Second one is not a living thing. Okay. Now let's try to understand what is multi-class classification. In multi-class classification, the goal is to set more than three or more than three classes in order to classify. In order to understand this thing, let's again take an example of optical character recognition. Over here, we try to identify the handwritten characters or digits. Suppose I want to identify what digits I have written. So I need to make class having 10 labels as starting from 0 to 9. Okay. So according to that, I will just make sure that each character that is handwritten will fall under any of this 10 labels that I have designed or 10 classes that I have designed. Okay. So like that, you can use multi-class classification and binary classification. If class labels are not mutually exclusive, then it's called as multi-label classification. So over here, let's consider one scenario where you build a system that identifies or that classifies movies into genres. So in traditional multi-class classification, you will call movie as one of the following genres like action, drama, or comedy. So your system will say that this movie is an action movie, this movie is a drama movie, this movie is a comedy movie. Like that, your system will work. However, in some cases, movies can be having multiple genres simultaneously, like a romantic comedy movie or an action adventure film. Like that, you can have multi-label classification. So, multi-label classification, a movie can be assigned to more than one genre. For instance, a romantic comedy movie can be labeled as both romantic and comedy. The labels are not mutually exclusive, allowing for multi-categories to be associated with a single instance. Now let's try to understand this thing with a function approximation concept. We think of a classification process as finding a function that maps the movie features X to the genre's label Y. Okay, so each genre is like a binary output that is 0 or 1, which indicates whether the movie belongs to the genre or not. Okay. So we just say mathematically that y equals to f of x. Here y represents the binary vector of genre labels and f of x is a function that approximates the relationship between the movie features and the genre labels. So after studying all of this, we got to a conclusion that classification uses training data in order to identify their labels. So in the training data set, we already have predefined features with their labels. And now, if we get a test case, we are going to have the set of features and then using that set of features and the training data that we have, we are going to predict what's going to be the label for that particular object that we get. So, this is what you call a classification model that is falling under the supervised learning. Now let's try to understand what is the problem with this model and why do we need to use probabilistic perspective to this model of machine learning. There can be a case where training dataset is not sufficient to identify in which category or label the test case falls into. Over here, you can see on your screen right now, there are two labels 1 and 0. and different sizes and shapes of objects are falling under these two categories. Over here, there is one table that is showing some features and their corresponding labels as well. So if you look carefully to these features, you can understand that if something new will come, I will easily identify in which label this test case will fall into. But now look at this image. Well, when you look at this semicircular kind of an image, you are not able to identify in which category this thing will fall into, as this is a new shape that you have not seen in your training dataset. So if training dataset is not large enough to identify what is going to be the label for a particular case, then that training dataset is of no use. So what can we do when we get new kind of features or when we get a new kind of values for the features? Over there, we have to use something that is not traditional machine learning, and that is why we are studying probabilistic machine learning. When such ambiguous test case is passed to the machine learning model, the machine learning model tries to return probabilities for different labels. It is similar to multi-class or multi-label classification, as over there we are going to have multiple labels having 0 or 1 binary number that is saying that that particular label corresponds to the class or corresponds to a test case or not. So yeah, that was really a good example, but not something that we are talking right now, because over here we are just checking for the probability. But at the end, we are only going to assign this particular test case to the label having the highest probability to have this particular test case. So this is how this model works. And that's what we need to do. Over here, we understand machine learning model. We try to find out what is the problem, and then we try to find out the solution using probability. And it was really easy with probability to solve this particular solution that would not be solved with the traditional statistical machine learning. So I hope you understand the agenda of this video, that we are going to talk about probabilistic machine learning models, not just traditional machine learning models. So there can be a case that in this video you will not understand what's going on in the solution because you might not be aware of some theorems used in probability, but it's totally fine. You can still watch this video, and then from the very next video you will be able to understand about all kinds of concept and machine in probability, and you can easily be able to map out all these problems with those solutions that you get in the next video. So it's up to you whether you study all these theorems right now by pausing this video, or you stick around with this video and then you watch the next video. So yeah, that's what you can do. In order to solve this problem, we are going to use conditional probability. Well, conditional probability is like you are going to find out the occurrence of a particular case on basis of some other cases, or when it depends on some other cases, you add those things. So it's like conditions. So over here you can see P of y slash x comma d, where y depends on x and d. So the probability of y will be depending on x and d. So y is my label, x is my input set, which is also over here represents a input vector, and you can also call this as a test case. And d is my training data set that I have. Okay, so when you look carefully over here, we can see that we are going to get some probability, which is again a vector of length c. Here the c represents number of classes, as we are going to have a binary case over here because we only have two labels, 0 and 1. So in this case, we try to find out the probabilities for both of the cases, then we are going to end up getting 1 as a sum, because p of y equals to 1 slash x comma d plus p of y equals to 0 slash x comma d will be always equals to 1. Because if you toss a coin, then probability to get a heads will be 50%. Then probability to get a tails will be again 50%. Okay, so if I set the probability like the probability to get a head will be 60%, then automatically the probability to get tails will become 40%. Okay, so that is why we are not going to take two of the cases over here. So the most probable class label is called as Moore of distribution or map estimate. Here, MAP stands for maximum a posteriori. Now, even if I pronounce this incorrectly, you can search online, and I'm really sorry for this. Coming back to the point of yellow circle, still after using conditional probability, we are not getting probability near to 1 for any of these cases. That means the probability of this yellow circle to be a part of label 1 is still not 100% or closer to 100%. So in probability, we say it as from 0 to 1. Okay, so it is still not closer to 1 or 100%. At the same time, it is still not closer to 1 or 100% in case of label 0. Okay, so that's why we just say we don't know, rather than just estimating something that is having higher probability. Okay, so this is really important in case of medicine and finance, because over there we have to manage risk. In 2011, something magical was unveiled by IBM. Well, it was a computer system called as Watson, which was built to play word puzzles. It was even able to beat the top human champion during those days. Well, Watson uses a variety of interesting techniques, but the most patent one for our present purpose is that it contains a module that estimates how confident it is for its answer. Well, that's what we do in probability. We try to find out what is the probability for certain case. The system only chooses to buzz in if the answer is sufficiently confident it is correct. Okay, so if the thing is correct, then only the system will say that yes, it is going to be this answer, or else it will not do it. Similarly, Google has system known as SmartAs, ad selection system. Now we are going to talk about SmartAs later on also. Now this is not something that you think. This is a model that Google uses that predicts the probability when you click on an ad based on your search history and other users and ad specific features that was released by Google. Okay, so this probability is known as click-through rate or CTR. Okay, so we all know about CTR. If not, then you should know about CTR, and can be maximized. This can be used to maximize the expected profit. Okay, so later on in this video series, we are going to study about SmartAs as well. So over there, you will understand the principles behind SmartAs and what was the main agenda behind creating this thing by Google. Now let's try to understand the classification model using iris dataset. You can see an image of a flower having two parts over here. The first one is petal and the second one is sepal. Both of this part contains length and width. And using this, we try to predict the species of the flower, or we try to predict the label of that particular flower. So here you can see we have three species in general. The first one is versicolor, Satosha, and the last one is Virginica. So these are the three labels that we get in our iris dataset. Well, over here you can see the iris dataset in VS Code. Basically, it's iris.csv, and CSV stands for comma separated values. So all these values are comma separated, and you can assume this as a table. If you try to visualize this thing, you can see we have the first value as sepal length over here, and then we have sepal width, and then we have petal length and petal width. At the end, we are going to have the label of that particular flower of any row that you choose. Okay, so let's say the row 5th is going to have a sepal length of 4.6, and like that we have other features, and at the end the species of this particular row is going to be Satosha. Like that you can check out for all these values. So this is basically my training dataset that I get. It contains around 150 values over here, as iris dataset is a standard dataset that we use for classification models. So this is just a dataset for reference that we use to understand about this model. Now let's try to code this thing using Python. The thing that you look on your screen right now is Google Colab. Well, we use this Colab, which is like a website, but it's like an online code editor that you can use in order to perform your machine learning code. Well, you can also use other things over here, but if you are a beginner like me, you should definitely use this Collaboratory instead of using any other thing. So what you need to do over here is that this is our cell that we are going to use in order to run the code. So you just have to click on this button over here and this will run your Python code. So if I say print and then I say Mayank, so as soon as I run this thing over here, I will be getting Mayank as the output. Okay. So of course we don't need Mayank as an output. We need to perform the classification model that we have for the iris dataset. So the first thing that we need to do is we need to import certain libraries for the use of this classification model. And the libraries that we need to import is, the first library is Seaborn. Seaborn is a data visualization library that we use in order to visualize the data. Okay. Apart from this, we are going to import matplotlib. And in that, we are going to use a specific library that is called as pyplot. Okay. So we'll import this as plt. And after that, we are going to import another library that we call as sklearn. See guys, matplotlib and Seaborn both are used for data visualization. But now sklearn is like a complete combination for various machine learning models. Okay. So what we need right now is iris dataset. Although we have CSV file in our computer that we can use for the classification model, but we can use the same from the sklearn library, because over there we have a dataset that contains all datasets, or basically the datasets that we use for study. Okay. So we'll say that from sklearn, let me just change this to from sklearns.dataset, import, and what we need to import is iris dataset. Okay. Iris dataset. So we'll write this as load iris because that's how it is stored in the sklearn dataset. Okay. So after this, you need to just come down and okay, we have a S over here as well. So that's why it is showing error. So now error is gone. Okay. So at the end, we have another important library, which we call as pandas. Now, pandas is library that is used for the handling of data frames. And that is why we import this thing. Although you must be not aware of what's going on in this library, and it's totally fine because you are a beginner, but still you should know about the basics of Python and how you import these libraries. So if you are clear with this, what is going on over here, why I have written Seaborn as and then SNS. And if you don't know, then let me just tell you that we don't write Seaborn everywhere. So instead of Seaborn, we'll write SNS. And similarly, we are not going to write matplotlib.pyplot. So we'll just write plt. And the same for this two other libraries that we have. Okay. So after that, we are going to create one more cell over here. And in that set, we are going to load our iris data. Okay. So load iris dataset. Okay. So in that, what we need to do is we create a variable as iris. And in that variable, we first store the value of iris dataset. Okay. And after that, we try to create the data frames of this iris data. So we'll just say that iris df, which stands for data frame. And in that, I'm going to use the pandas library. In that, we have a function as data frame, which takes two variables. The first one is going to be the data, and the second one is going to be the column. So in data, I'm going to have the iris.data, and I'm just going to say column, column, columns, we have iris.features. Okay. So I'm going to just say feature, and then we have names. Okay. So I hope it works. Let me just check it once. Okay, of course, this is going to work. Okay, so yeah, that's what we do in order to load the data. So after you load the data, we have to assign the classes as well. So we are just going to say that iris.df, and then we're going to just pass on the class. And after that, what we need to do is we need to just assign this class as iris.target. And then we just say names as iris.target. Okay. So if you don't understand this line, then don't panic. We are going to look at this libraries individually in between of this series only. But we actually don't need to study a lot about this libraries for now because we are going to study probability first. But still, if you don't know a lot about this all libraries, it's totally fine. We are going to make a video for that as well. For now, just understand that we have created a comma separated file and we have assigned the data as iris data that we get in this load data function, load iris. And the columns are basically the features. So at the top, we have features, and in between of that, we have all the labels. So let me just do one thing. Let me just show you what is going on. Okay. So let me just try to print the first 5 numbers or the first 5 rows of the iris dataset. Okay. So in order to do that thing, let me just use over here, first 5 rows. So in order to do that thing, we can do it manually, or you have a function for that. So we'll try to use the function. Well, that function is head, and let me just correct this, dot head. Okay. So head is a function that you can use in order to find out the first 5 rows of a data set. So that is a CSV data set. Okay. So if I try to run this code, let me just first run this code. And before that, let me just run this code as well. And now let me just run this code. So as soon as I run this code, you can see I'm getting sepal length, I'm getting sepal width, I'm getting petal length, I'm getting petal width. At the end, I'm getting class. So class is my Sitosha for all 5 cases, because the first 5 rows that I have are going to have the same class as Sitosha. But I can also have some other classes that are basically versicolor and virginica. Okay, so we can have those labels as well. But for now, we only have this labels for the first 5 cases. And this is again just a random thing that depends on the dataset. Over here in this dataset, I have the first 5 values as Sitosha. Okay, so for this particular feature. So my features are my sepal length, my sepal width, my petal length, my petal width. Okay, so that's how you just try to find out the first 5 rows. After this, let me just come back over here. And now let's try to set the color palette for the 3 labels that we have. So let me just create a variable as palette. And this will be like a dictionary. If you don't know about dictionary is like phone numbers with name. Okay, so like a contact list that you have in your mobile phone, which contains the name of the person and its contact number. In the similar way, we have dictionary. So we create dictionary like this using this curly braces. In that we have the first thing as key. So over here, my key is going to be my label. So my label is Sitosha. Sorry for the wrong pronunciation again. And the color that I'm going to use for this is going to be red. Okay, so what I'm doing right now is, let me just put what do you call this? I just forgot. A comment over here. Now this is how you put comment in Python, and I'm going to upload just upload this whole code in the description, so you can just download this code if you are not able to understand. Okay, so you can check out over there as well. Okay, so we'll just comment it and say that we are trying to set the color. Oh, now I am making spelling mistakes as well. Color palette for the 3 classes or spaces. Okay, so first one is red, and then we have versicolor, and our versicolor is going to be, let me just check the spelling of this. Okay, it's correct, versicolor. So this is going to be, let's say, blue. And then we have, let's say, what's the last one? Last one we have, I guess, virginica. Okay. And this is going to have, let's say, green, I guess. Okay. So yeah, after this, we have set a dictionary having 3 keys, which are our class or species, or basically labels. I'm just going to add labels over here as well, so there is no confusion. Okay. So this is our labels, and this color represents to that particular label that we have. Okay. And after that, what we need to do is we need to create a matrix. Okay, guys, we need to create a matrix that is going to have the relation between all the features by itself. So it's like a cross multiplication of all these features that you can see, these 4 features by itself. Okay, so sepal length with sepal length, sepal width with sepal width, and sepal length with sepal width. So like that. Okay, so let me just try to show you this by writing the code over here. Before that, let me just run this line. If you don't run this line, then of course the effect would not create, okay? And then you will get error. So make sure that you run the cell before you execute to the next cell or you move to the next cell. So now we have to do pairwise. We'll call this as pairwise. Scatter plot, okay? With Seaborn, okay? So we are going to use Seaborn over here. Again, you can use any other thing as well, but Seaborn is a good visualization tool. So we'll use Seaborn for now, okay? So in Seaborn, the first thing that we do is we set the style as ticks. Okay. Now again, if you don't know about anything related to Seaborn or like any other module that we studied so far or libraries that we studied so far, it's totally fine. We are going to study about this in a detailed manner in the further videos. Okay. So the style will be ticks over here. So ticks is basically a style that we can use for our graph that we create. Okay. So it's a scattered plot that the style is ticks, and in that now we'll just add the pair plot. So pair plot is like you are going to create a pair or a matrix of this all features with itself. Okay. So we are going to have a pair plot of iris df. So iris data frame, and the hue is going to be my class. So we already know that what is class. We have created this label over here. Okay. So the hue is going to be this one. So under this influence, my graph is going to be created, and I'm going to have my markers as, let's say, O. And again, we have to put this as a character. So we have O, S, and let's say D. Okay. So let me just put it like this, D. And after that, we have palette. We have to assign the palette that we created above. So we'll say that palette equals to palette. Okay. So I hope the spelling is not spelled wrong. Okay. After that, we just need to show the graph. So in order to show the graph, we'll use matplotlib.pyplot. So we'll just call this as plt.show. Okay. That's a function in order to show the things that we have created so far. So yeah, let me just do it like this. And let me just try to run this code. And let's see what happens. Okay. So yeah, there is some error, I guess. There should be no error, but still there is. Okay. So you can see over here, we have a matrix of graph. Don't get confused. Let me just explain you what's going on over here. You can see petal width, petal length, petal width, speckle width, speckle length. Okay. In the similar way, we have speckle length, speckle width, petal length, petal width. Okay. So this is a graph that you can see between petal width and speckle length. And this is the graph between petal width and speckle width. And this is the graph between petal length and petal length. Okay. So the row that you can see, the diagonal over here, the diagon over here is basically a histograph, which is like a relation between the same features. Okay. So for the same features, you can see that for the red color, which is our Sitosha is the most. And then for the Versi color, it's slightly lesser. And then for the Virginica, it's slightly more less. Okay. So in the similar way, you can see the other histograph over here for the speckle width. Okay. So in case of speckle width, the highest is the Virginica, and then we have the blue one, which is Versi circle, and like that. So if you try to understand all of this graph by yourself, you just have to look at this graph and understand what is going on. Now over here, let me just show you certain things. Okay. So if you look this over here, you can see this red one is my Sitosha, and the blue one is my Versi color, and the green one is my Virginica. So you can see how the clusters are forming over here, how the classification is going on over here. So this is basically a classification model, not a clustering model, because we are not clustering these models on the basis of distance. Instead of that, we are trying to find out the common patterns on the basis of the training data that we got. So it is really important to look at all this graph and try to find out the relation between each of these things. So yeah, that's what the classification model is all about. And that is what you can say the classification model of iris dataset. So I hope you understood the basics of classification model. Even if we just have scratched the surface of classification model, and there is yet a lot to explore, but it is acceptable for now because we just need to understand about the basic models in machine learning and then give a head start towards the probability. Although, if you want to explore more about classification model, like learning about how to do character recognition using classification model, you can check out the link in the description for the Google Collaboratory, where you will see the working of this character recognition. Although I recommend you guys to first go through the basics, but if you already know the basics, you can check out that part as well to enhance your knowledge. And if you have done those things, if you are back to the video, now let's talk about what is regression. Well, imagine a stock market trader is coming to you and you are a machine learning engineer. All he needs to do is he needs to try to analyze his past data that he has in order to predict what can be the best case for the future. So right now, you have data. That is why this case will fall under supervised learning or predictive learning. But this time, you can't just put this data in labels because you have to find out the value of the particular thing in future. And you don't know what's going to be the value. It can be 10,000 from 5,000. It can be 5,000 from 5,000. It can be 2,000 from 5,000. It can be anything. So over here, you basically don't have labels. And if I try to explain this thing in a single line, that would be in supervised learning, we have two types. First one is classification model. Second one is regression model. In regression model, we don't have labels. In classification model, we do have labels. So yeah, that's what it is. So now let's try to understand this thing in a more depth order, in more mathematical order, so that you can understand and apply this concept. Unlike classification model, where we have multiple features, over here in regression, we only have a single feature or a single input variable which we call as x. Corresponding to this, we get a response variable or an output variable as y. Now this y is always going to be continuous. Now if you are familiar with math, you'll probably know what is the term continuous means. But if you are not, you would probably think that continuous means something that goes to infinity. But that's not the case. Continuous is a term used to define the function. Now, in maths, we have different functions. A function can be either a continuous function or a non-continuous function. So, for example, if I say I have a straight line function that is f of x equal to mx plus c, this is always going to be continuous because a straight line will never break in between. So, continuous means something that doesn't break in between. Okay, in a similar way, we have examples of polynomial functions like quadratic equations and cubic equations, which are always going to be continuous. In a similar way, we say logarithmic functions are always going to be continuous. We have trigonometric functions, we have exponential functions. All these functions fall under the continuous category. Okay, so continuous is the term that we use in math in order to define a function. And right over here, our output is always going to be continuous. Okay. Now let's try to understand this thing with a data set. Right over here, you can see data points are scattered all over the graph uniformly. And we have a data set over here that is basically having some sort of relation between two variables. Okay, so all I need to do is I need to apply the regression to this data set. Okay, so let us understand what we can do over here. We can apply different models, different continuous functions. So the first function that comes to my mind is a straight line function, which we call as a linear function. So a straight line function is f of x equal to mx plus c. If I apply that to this model right over here, this data set right over here, you can see I get something like this. Again, I can apply a different model to the same data set, which we call as, let's say, quadratic function. Now a quadratic equation looks something like this. So now you get a different model. So like that, for the same data set, you can apply different regression that you call as a linear regression or a polynomial regression or a logarithmic regression or any kind of regression. Okay, so that is how you can use regression in order to perform some basic operations with your data set. So you can get a continuous output. Okay, so that's it for supervised learning or predictive learning. In the next video, we'll try to understand about unsupervised learning.